Again, thank you for being at today's meeting. We want to start chapter 9, and it's an introduction to 3D. So like baby steps into working in 3D space. Okay, so for me, I'll be trying to grade your exams, and for you, I made some homework. This homework is due Saturday the 1st. Okay, yes, and again, hey everybody. Let's just do some casual easy notes. First of all, chapter 9 is working with functions in more than one variable, or in several variables. Cool. 9.1 is the 3D coordinate system. So a lot of things we've done in 2D still work in 3D. We'll just add an extra dimension. Okay. So let's draw a quick sketch of XY axis. So we're going to take this plane, put it flat, and have another axis, the z-axis, come up from the origin. So go to 3D. We'll have 3 axes. 1, 2, 3. Right there is the origin. And we're going to use the right hand rule. Okay, first of all, before we go there, let's mark these. This would be a positive. Yeah, we'll do the rule and then the marks. So right hand rule. Okay, so imagine that you're standing here at the origin. Actually, if we want this person. We're going to draw this dotted line, and then this is an arm. And then a dotted line, and that's your arm, and the person. Okay, and then that extra axis. Okay, the right hand rule means your right hand points towards the x-axis. Let's put x. Okay, right hand points to x-axis. And there's another way that my teacher explained it, so we're going to draw a new picture for the right hand rule using your right hand as a sketch. But before we go there, let's go on the x-axis and make some marks. This way towards us is positive. So +1, +2, +3. from the origin over that way would be positive numbers. Positive 1, 2, 3, 4, 5. Then the z-axis, let's go up. 4. Positive 1, 2, 3, 4. Okay, so there's the explanation from the book for the right hand rule. The way I was shown was to draw your right hand. So you got like a palm and a thumb with your fingers. The fingers point to X, and then on this side is Y. And then if you curl your fingers in, that way is Z. So X is here, Y over there. If you close your hand, you make a thumbs up. So this is how we're going to draw our 3D coordinate system for like the rest of the book, for all of our homework, and everything like that. Let's plot some points. We're going to plot 0, 0, 2, and 2, negative 1, 3. So we'll draw the x-axis, the y-axis, and then z goes up through the middle. Okay, and when you kind of like move along, I try to stay parallel with that axis so that I get a good drawing. This is where doing online homework comes in handy. I think it will be, well, I haven't tried it yet, but it should be kind of fun to use your graphing utility to plot your points. We're going to sketch 0, 0, 2. Okay, 0 for x. So on this axis, we go here. 0 for y. So moving along this axis, stay right there. Up 2 for z. So right on that. Okay, here's a new x. We'll call it x1. X2. Sorry. X, Y, Z. So Y1, Z1. Or you just call it X, Y, Z. It's fine. So X1 is 2. Go here to positive 2. Negative 1 for Y. So we want to go back. I'm going to draw a little dotted line parallel to this line. So back 1. So this way 1, and we're going to go meet here and then up 3. So let's go 1, 2. This is 3. I'm going to go parallel to the x-axis. Draw this kind of line. I'm going to go straight up here. That's my point. So 2 for x, -1, wait, hang on. Maybe like here, -1, 2 for x, -1 for y, up 3 for z. Okay, the next thing we're going to sketch is a plane. Okay, so a graph is a set of all ordered pairs that satisfy your function or equation. So we need the set of all pairs, or not pairs, triplets, like x, y, z, all ordered x, y, z guys, such that y has to be 5, x is any number, z is any number. So y is 5. X and z exist in the real numbers. So we're going to put oops, okay. These are points x, y, z such that y is 5. X and z are in the real numbers. Okay, x comma z exist in the real numbers. So let's set up the x, y, z axis. Okay, so from the origin, we need, let's just start with some point, like 0, 0, 5. So 0 for x, 0 for z, and we're going to go along the y-axis to 5. So that's just one point in your graph. We can also go like just from there, y is 5 and x is any number, so like this line, all the points on that line are in the graph. Also, let's start here and say y is 5, x equals 0, and z can go up and down and be any number it wants to be. Okay, we can keep doing that with going out to y equals 5, but then having any value for z. And then going over to y equals 5, but we can come along and have different values for x. And z. So to help draw the picture, we're gonna like put this all in a nice square that represents the plane. Trying to sketch. Let's go with so it's kind of like a sheet of paper that's going through that point 0, 5, 0. Okay, let's keep going. So the different kinds of formulas we're going to do are the distance formula in 3D, the midpoint formula in 3D, and the equation of a sphere. Okay, for the points, x1, y1, z1. And x2, y2, z2. Midpoint. Okay, actually it needs a little more. The midpoint of the line segment between those points. The midpoint of the line segment joining the points is okay. So before we write it down, it's going to be the average of your x values followed by the average of your y values, and then follow that by averaging your z values. So add them together, divide by 2. Add these together, divide by 2. Add together, divide by 2. Is okay, x1 plus x2 over 2. y1 plus y2 divide by 2. Okay. z1 plus z2 over 2. Okay, so we will do the midpoint of the line segment that connects 8, 0, negative 6 with negative 7, 4, 5. Let's see. Connect seems fine to me. The point 8, 0, negative 6 with or 2 will be save space. The point negative 7, 4, 5. Okay, so you're going to start from scratch, go back to rewrite the formula. x1 plus x2 divided by 2. Do y1 plus y2 divided by 2. z1 add z2 divided by 2. And let's label x1, y1, z1. This will be x2, y2, z2. So we're going to add 8 with negative 7 and divide by 2. And work with 0, add it to 4, add it to 2. Negative 6, add to 5, divide by 2. so first part is 1/2. The y value would be 2. And for z, I have negative 1/2. So we need to talk about the distance between 2 points in 3D. Okay, so we need 2 points. We're talking about the distance between the points x1, y1, z1. Is similar to finding the distance in 2D, but we're going to add an extra piece. So distance will be square root of x. You could either do x1 minus x2 squared, add y1 minus y2 squared, add z1 minus z2 squared, as long as it's consistent. Or we can go the other way. So we're going to do x2 minus x1 squared, add y2, subtract y1, and square, then add c2 minus c1 squared, and done. So there's this extra part where we have those z values. So we will find the distance between the points 2, negative 1, 7, and 1, negative 3, 5. Okay, I know it's on the board, but I just like to rewrite things. It helps practice and memorize and learn. So we start our scratch work with the distance formula. Let's write again. It's, we could put x1 minus x2 squared, and then add y1, subtract y2 squared, add c1 minus c2 squared. This will be x1, y1, z sub 1. X2, Y2, Z2. Okay, so the root of 2 minus 1 squared. add -1 minus -3 squared. Add 7 minus 5 squared. All right, we've got 1 squared, which is 1. Added 2 squared, 4. And that last one is another 2 squared. Root of 9 is going to be 3. And I think that we have, nope, we're out of time. So we'll have to come back next week and talk about spheres. Then traces. So where a trace is where a surface, like say a sphere, intersects a plane. So like a slice of that sphere. Okay, we'll stop for today. Thank you for being at this meeting.